Okay, so welcome to this video lecture. So it is the continuation on the lecture on geomorphic processes. So to have a recap, we have here our learning objectives, in which the previous discussion highlighted the endogenetic processes and the description of the endogenetic processes. And we had also uh, gone through with geomorphic processes through a diagram. And actually, this is the diagram wherein we have an initial discussion on endogenetic processes. So we have the faulting and folding, and then the diastrophism, metamorphism. So folding and faulting are just the process of endogenetic under diastrophism, in which the movement could be vertical or horizontal. So vertical, it is associated with the term eperogenic, or it is the formation of continents, wherein the vertical movement, of course, it is either upward or downward forces, and then the same movement under the astrophism is we have also horizontal or orogenic, or what we call the mountain building. So, we have several examples and the pictures witnessed last time about the orogenic and eperogenic as well. So orogenic as a mountain building, uh, it could be the formation of fold mountains, or it could be fault mountains. So we all know that the force of compression tends to squeeze your material. So the tendency here is under a plastic deformation, wherein evidently your material would fold. And if we have tension, of course, it will crash. Okay, so there will be a crashing action of your material or earth material. So that is the difference between the fold and the fault mountains. And here we also have discussed an initial insights on metamorphism, wherein metamorphism is actually an alteration on the structure or minerals or geologic structure. So the key term here is actually when we have certain material underneath. Of course, we know that as we go down, the pressure increases. Okay, so the pressure increases as we go down, and as we go down also, there is the presence of hot material like the magma, wherein it will have significant effect on your material underneath, that will be eventually present later on the or the surface itself. Okay, so the term here is the heat and pressure, or the temperature and pressure will tend to have a reaction on the material, especially rock formation. So well, as an additional definition on the process, we have this metamorphism. It is actually the assemblage of the mineral, of course, because of the high temperature. So with the reaction of the atoms or atomic minerals of those rock, it will have a texture variation, the arrangement of the atoms, atomic structure, and the physical and chemical changes. So it could be that your rock will have a various strength depending on the layers, how it is formed, that is caused by factors such as crustal movement, the activity beneath or the magma activity, and the thermal fluid change in the earth. So those are the metamorphism. So before we proceed to the types of metamorphism, I would like you to have here a video clip on the process of metamorphism. So let us listen carefully to this.
Metamorphic rocks are rocks that have undergone metamorphism or change. When rocks are subjected to temperatures, pressures, or chemically active fluids higher than what is normally found at Earth's surface, or within about the first kilometer of Earth's surface, these rocks will undergo physical and chemical changes and create new metamorphic rocks. How much pressure and temperature? What kind of changes? If a rock is subjected to so much heat that it fully melts, it becomes a magma and is igneous, so metamorphic temperatures have to be lower than that. If surface sediments are subjected to a little heat or pressure, or cool fluids, just enough to compact or cement sediments, or leave crystals in pockets or holes, it's sedimentary. So metamorphic rocks sit in the zone between these two environments. The metamorphic rocks that form under these change conditions depend on the original parent rock chemistry, the exact pressures and temperatures to which the rock was subjected, and the amount of water available for chemical reactions. Where do we find metamorphism happening on our planet? When we bury surface rocks beneath layers of sediment or lavas, these rocks will sink deeper in the crust. The deeper they go, the higher the pressures and temperatures, and hence the higher the grade or intensity of change or metamorphism. These temperature and pressure gradients will vary in particular geologic settings, such as subduction zones or between converging continents, but where rocks outside these areas are gradually buried over time, their temperatures and pressures will rise steadily together. There's usually no large source of water in burial, just whatever water happens to be inside the mineral formulas or is trapped in holes in the rocks. Not surprisingly, pressures get quite high where two plates collide. When the two colliding plates are made of continental crust, there will be no subduction, and the crust will be folded and faulted. Pressures will be most extreme deep in the middle of these two plates. Temperatures will also increase, especially the deeper we move into the center of the convergence zone and beneath the crust under the plate boundary. Like with burial metamorphism, any water that's available comes from water trapped in the rocks or in the mineral formulas. What happens at subduction zones? Pressures are also quite high here, and get higher the deeper the plate sinks into the mantle. But the temperatures do not rise at the same rate because the subducting plate is cold and insulated, and sinks faster than temperatures can equilibrate. So subduction zone metamorphic settings are characterized by high pressures but low to moderate temperatures. Water content can be quite high because of the high amount of water absorbed by sediment and rocks in contact with the ocean water for the potentially hundreds of millions of years that the subducting plate was being pushed across the oceans. What happens around volcanic centers? These areas, of course, have high amounts of heat and also water that comes from surface fluids, rains and groundwater, or coming off the magma chamber. So temperatures can get quite high, while there is no added pressure, so pressures remain low. The major changes that occur in the rocks around volcanic centers are chemical changes facilitated by hot chemically active fluids interacting with the original rock material. Rocks around the edges of a magma chamber undergo what we call contact metamorphism. Rocks further away can be metamorphosed by the hot fluids that migrate upward and outward from the volcanic zones. We call that metamorphism hydrothermal metamorphism. What are the physical changes that can occur during increased metamorphism? With increased pressure, we get increased density. Also, any minerals that have a long or flat axis will align themselves to equalize the pressure, a process called foliation, which we will describe more in the next video tutorial. Additionally, under increased temperatures, crystals can actually grow larger. How? Adding heat to a rock will make atoms vibrate at greater and greater energies or speeds. This increased energy can allow the atoms to migrate across the solid without melting. Atoms will use this added energy to seek out new bonding partners if nearby. For example, atoms in two side-by-side crystals of the same material will migrate across the boundaries, obliterating them and growing into a new, larger crystal. In addition to physical changes, there are chemical changes that can result from added heat. As the atoms increase their energy and migrate, they can react with atoms in nearby minerals and create new minerals that are more stable at the new temperatures and pressures. If chemically active fluids are present, these fluids can bring in new atoms and make those available during the process. They can also take some away. If the new minerals that form are stable under narrow temperatures and pressures, they become valuable clues to the story of the rock. Such minerals are referred to as index minerals. For example, quartz is stable under all pressures and temperatures in the metamorphic realm, so finding quartz in a metamorphic rock doesn't tell us much. However, the mineral garnet is stable only at higher pressures and temperatures, so if we find garnet in a rock, we know that it had to be subjected to those higher pressures and temperatures. As discussed in the Inside Minerals video, these three minerals, kyanite, andalusite, and sillimanite, are polymorphs, different crystalline structures but same chemical formulas, so three different minerals. These minerals are excellent index minerals because when the pressure and temperatures change in a metamorphic setting where one of these minerals exists in the rock, the mineral will transform into one of the others. Finding kyanite in a rock, for example, indicates that pressures could have gotten quite high, but temperatures not. We know from earlier in this video tutorial that such a situation exists in subduction zones. So kyanite minerals are good clues that a particular rock metamorphosed in a subduction zone. Pause now.
Okay, so that is the end of the video. So on the video, we have witnessed the process on several types of metamorphic or metamorphism. So actually, it has discussed several types, as you can see on the slide here. And of course, we'll go into details on this type of metamorphism. We have from boreal metamorphism, we have the regional metamorphism, and then the seafloor metamorphism, subduction zone metamorphism, contact metamorphism, and then shock metamorphism and dynamic metamorphism. So first, we have the boreal metamorphism. So it is characterized by recrystallization of the minerals, and of course the minerals will tend to grow, and the temperature is up to 300 degrees Celsius, wherein the depth is around 100 meters and above. So normally boreal metamorphism occurs to rocks buried beneath sediments to depths that exceed conditions in which sedimentary rock form. Because rocks undergoing boreal metamorphism encounter the uniform stress of lithostatic pressure, so not more on sa differential pressure, so that they would not develop a concentration of the elements like foliation. Okay, so by and by, in a short while, I'll discuss about foliation na tinatawag, ano. So, what about this lithostatic pressure? So, normally, kapag meron tayong differential pressure, it is a pressure that is more on larger pressure along one direction. Okay. So, for example, when we have a pressure underneath a certain strata or rock strata. So the pressure, of course, when we talk on differential, the greater pressure is on the vertical because of the gravity of the material, okay, or the self-weight of the material. In boreal metamorphism, when we say lithostatic pressure, it is that there is a confining pressure. So meaning it is a high confining pressure wherein uh, confining pressure increases, rocks deform by a decreasing volume. Okay, so the volume is actually decreasing, unlike in a differential pressure. If if a greater pressure is on one direction on or one axis, if your force is a compression, of course a pressure is a compression, it will tend to shorten your material on that direction. Okay, say for example yung x-axis mo, in-squeeze mo yun, so yung x-axis, the dimension will tend to shorten, ano. However, pag shinorten mo yun, hahaba naman yung y-axis. Okay, hahaba naman yung y-axis. So in a certain deformation along the x-axis, in a certain shortening along the x-axis, there is a corresponding lengthening along the y-axis because the force is greater on your x-axis. So there is a concentration of the force along the x-axis. While if we do not have a differential pressure, meaning uh, forces or the pressure acts on all directions, so therefore your volume will tend to decrease, or in short, there will be a confinement of your uh, material, and therefore that will be under a metaconglomerate. Okay, so yung metaconglomerate, it will be formed up uh, because of boreal metamorphism. So kung titignan natin, parang yung metaconglomerate, it is a series of pebbles, parang it is a cemented series of pebbles formed out of the boreal metamorphism. Okay, parang nakumpak yung mga sediments on the larger or rounded materials. Okay, so kung titingnan natin, parang nasemento yan na pebbles, and that is a metaconglomerate. So evidently, metamorphism is not foliated. So this is where I'm going to explain here what is meaning of the foliation. As we can see, in the foliation, there is a concentration of minerals. Okay, there is an assembly of minerals because of high temperature and pressure. While in non-foliated, there is no, the grains are not parallel. Okay, and the foliation or foliated means parallel arrangement of mineral grains that gives the rock a striped appearance. Okay, so foliation forms when pressure squeezes the flat or elongate materials within a rock so they become aligned. Okay, so yun ang difference ng foliated at non-foliated rocks. So from the boreal metamorphism, we also have this one. So there will be a lot of rocks that will be formed out of this large-scale metamorphism. So regional metamorphism is actually caused by the converging plates that are colliding, that are in collision with each other. So it is a combination of the squeezing force plus the weight of stacked rocks. And as we go deeper, there will be uh, the high grade of metamorphism that will cause more foliation on the rock. So as we go deeper, foliation will be more evident on your rocks. Um, with the average increase in temperature with respect to the depth as we go deeper per I think per hundreds it would increase to at around 30 degrees Celsius increase per depth. Okay, so therefore, if we have a depth 18 kilometers below surface ground, so the temperature is estimated up to 500 degrees Celsius. So regional metamorphism could be low grade metamorphism, medium grade, and high grade metamorphism. So again, as we go deeper, the more high, the higher grade of metamorphism occurs. So as we can see here, we had a lot of changes with respect to the increase in depth. So from slate, we have phylite, schist, gneiss, and that's it. And beneath that is migmatite, or the hot material, hot melted material, below gneiss material. Okay. So for regional metamorphism, we have several type of rock here. So with an increased metamorphism, above or the outermost layer, we have the shale, and then the next layer will be slate, and then phylite, phylite, and then the schist, and then the gneiss. Okay, so we can find the shales around our province, ano? So makikita to sa um, several mountains here in Kalinga, wherein we can see a flaky, sharp materials. Okay, so it is actually a fine-grained sedimentary rock that forms from the compaction of silt and clay size mineral particles that we commonly call mud. Okay, so this composition places shale in a category of sedimentary rock known as mudstones. Okay, so it is distinguished from other mudstones because it is fissile and laminated. So laminated means that the rock is made up of many thin layers. So fissile means that the rock readily splits into thin pieces along lamination. So here in the picture, normally shale uh, tends to fracture easily because it is fissile and laminated. So there are layers on it. So madali siyang i-crush and to split it into pieces. So it ha it has it ha it has special properties that make them important resources. So black shales contain organic material that sometimes breaks down into form into natural gas or oil, and then other shales can be crushed and mixed with water to produce clays that can be made into variety of useful objects. So aside from this, it could also be a source of material in ceramics, ano? So pwede siyang gawing brick, pwedeng gawing tiles or pottery, and it could also be a material to form cement, ano? Okay? So crushing of shale and heating it with limestone makes cement, okay, for the construction industry. So yun. So aside from natural gas, pwede rin siyang maging semento. Pwede siyang gawing brick, tiles, as well as ceramic. Okay, so the major composition of shales are actually clays. Okay, it is represented by a large kaolinite, and then morillonite and Eyelite. So, yun yung mga mudstones. So, this is the late tertiary mudstones. Okay? Yung mga shales. And then, from a deeper layer, wherein we have around a temperature of 200 degrees Celsius, we have the slate. Okay? So, we can see slate are more rounded compared to the shale. Medyo mas mapurol siya kaysa sa shale, because shale is a flaky one and it has a sharp edges. So it is a fine grained foliated. So kung makikita mo, um, medyo parallel na yung mga some of its minerals. If we have a closer look on the color, parang may mga stripe siya, but not that so much obvious. Okay, so it is an altered shale. Okay, kaya halos magkakulay sila nung shale. So it is a low-grade regional metamorphism because yan, medyo mataas na yan, kaya lang hindi gaanong kataasan yan when we talk of metamorphism. So the level of a grade is a low grade. So it is popular for a wide variety of uses. So pwede siyang gawing roofing, flooring, and flagging because of its durability and attractive appearance. So slate is also used as yung tablet. For example, yung mga markers sa sementeryo could be used. Okay? So those are some uses of slate. And then we have phylite, about 300 degrees Celsius temperature. So this is found on a depth that is more deeper than that of the slate. So still it is categorized as low-grade regional metamorphism. Okay, so it is because of convergent plate boundary. Yun nga, we are talking about regional metamorphism here. And we have some properties here. It is 1 to 2 on the most hardness. It is a measure of hardness. And it is fissile. Okay, just like shale, it is fissile. And then the grain size very fine-grained white mica achieves a preferred orientation. And then, of course, it belongs to metamorphic rock, and the texture foliated. Okay? Pero hindi naman gaanong foliated, but it is much foliated compared to your slate, ano? Ito parang yung mga foliation niya, parallel nga yan, but it is not that obvious. So here, kita mo naman may mga stripe na siya. Okay? So phylite, that is phylite. But not that too obvious. Okay? So the degree of metamorphism is in between the slate and the schist. So the mineral composition is a graphite, muscovite, cerisite, chlorite, or the translucent fine-grained white mica quartz, plagioclast. And then the most abundant mineral on this phylite is mica minerals. Okay, so phylite is a lustrous sheen rock. So it is often used as decorative stone in countertops. So it may be used as decorative aggregates such as floor tiles. Pwede rin siyang interior design, and the exterior building pwede siyang gawing cladding or maybe a garden decoration. So it also may be used in building facades for decorative crush stones, and pwede rin siyang gawing landscape when it is trimmed and it will become a slab. So pwede rin siyang gawing pathwalk. Okay, so those are the use of phylite. And interestingly, the color is usually gray, black, or greenish, and often weathers to a tan or brown. So when we say weather, it is subjected to decay because of the presence of water and oxygen. Okay? So meron din tayong tinatawag na rusting. So later on, we will go into details on the weathering of rocks. So for the meantime, let us have the picture of several rocks. Okay? So aside from the usual color, it could be a reflective sheen, often gives a silvery, non-metallic appearance. Okay, para siyang silver. Okay. And then from that, we have the schist. So this is developed when your temperature reaches 400 degrees Celsius, and it is much deeper than phylite. So from the low grade metamorphism, we switch now to medium grade metamorphism. So it is formed from mudstone or shale and has medium to large flat, okay, sheet-like grains in a preferred orientation. So iisa yung orientation ng grains, which can be obviously see on the closer look. So it is defined by having more than 50% platy and elongated minerals such as micas or talc. So kung titignan natin yung mga puti-puting yan, medyo siya para siyang elongated minerals. Okay, so it is more stretched minerals. So it is flaky in nature. So it is often finely interleaved with quartz. Para siyang naghalo-halo na. Okay? So the individual mineral grains in schist drawn out into flaky scales by heat and pressure can be seen with the naked eye. So kitang-kita natin yung crystallized flaky scales. Okay? So nangangaliskis ano. So schist is characteristically foliated, meaning that the individual mineral grains split off easily into flakes or slab. So the word schist is derived from the Greek word schizein, meaning to split, which is a reference to the ease with which schist can be split along the plane in which platy minerals lie. So, anong difference na ngayon on the phylites and the shales? So, yung kung phylite at yung shales, it is a fine-grained material. Ito, medyo magaspang siya because it is a coarse-grained metamorphic rock which consists of layers of different materials and can be split into thin, irregular plates. Okay? So, it is composed of largely platy minerals such as muscovite, chlorite, talc, ceresite, biotite, and graphite. Feldspar and quartz are much less abundant. So, meron kang makikitang glassy dyan pero hindi ganun karami, no? So, later on, yung susunod dito, may mas maraming crystal formation on the next mineral formation. So schist is not a very strong rock, so it is not often used as a building material. However, it can be used for garden decoration, paving, and sometimes sculpture. Okay. So next we have gneiss. So we have a trivia here that this term is an old German word meaning bright or sparkling. Okay. So the texture here is the same, foliated siya. And foliation on a scale of a centimeter or more. So kitang-kita na yung foliation, that the foliation is a stripe. You can see that the rock is striped with foliation. Okay. So the grain size, medium to coarse grained. Hindi siya masyadong fine. Hindi rin siya masyadong coarse. Unlike yung schist kanina, it is obvious that this is a coarse-grained material or metamorphic rock. Ito naman, hindi gaano magaspang. Okay? Medium to coarse-grained. So you can see here the crystallization of your material with the naked eye. And then sa hardness naman, ito matigas siya. So, comparing to the schist, yung schist, it is not that hard. Okay? So, the color varies. Generally, an alternating lighter and darker. So, madali siyang ma-determine. Basta may combination ng lighter and darker, tapos matigas siya with a stripe color, then we can identify that is a gneiss rock. metamorphic rock. So the mineral contents is a felsic mineral such as feldspar, no? And quartz. So yung quartz, generally, yun yung nag-form ng light-colored bands. Mafic minerals such as biotite, pyroxene, and amphibole generally form the dark-colored bands. So garnet, porphyroblasts, common. So other features, generally rough to touch. So uses, dimension stone for building faces, facings, paving, etc. So for the remaining time, perhaps you can group yourself um, with groupings composing of up to five members in a group, so that for the remaining time you're going to coordinate with each other, discuss to each other on your group where you can find these materials, okay, in Kalinga, so that later on you're going to obtain this material and be part of your requirement. So as an initial activity, discuss with your group where you can find this material that have been discussed, like I think first we have metaconglomerate. So metaconglomerate, saan tayo makakuha niyan? And then an example of foliated and non-foliated. And then specific, we get the shale, slate, phylite, schist, and gneiss. So remember that we are in a mountainous area. Of course, within our locality, it is available. Okay, so work with your group and have a good day. So thank you. So we'll just continue next meeting for the other types of metamorphism.